Hello everyone. The continuation of thermogravimetric analysis. The thermogravimetry analyzer consists of the following many instruments. Let us discuss one by one. The first one is the microbalance. It is the most important component of thermobalance. It is used to record a change in mass of sample or substance. So it is used to record the change in mass of some sample. An ideal microbalance must possess the following features. It should provide the electronic signals to record the change in the mass of substance. It should have the capacity of auto weight, and its operating should be user friendly. Modern microbalances have the ability to be not affected by the vibrations. So these are the essential features the microbalance must possess. So the second instrument is the recorder balance. There are two types of recorder balance. One is the deflection balances. Second one is null point balances. The deflection balances, there are following types: beam type, helical type, cantilevered beam, and the torsion wire. The deflection balances are the four types. In these balance, the conversion of deflected beam takes place in weight change. In this balance, elongation or contraction of spring occurs with the change in weight, which is recorded by help of the transducer. In this, the beam is attached to hard torsion wire, which acts as the fulcrum. In this balance, one end of the beam is fixed and on the other end the sample is placed. The second type is null point balances. It consists of sensor which detects the deviation from the null point and restores the balance to its null point by means of the restoring the forces. The third important component is the sample holder. The sample to be studied is placed in the sample holder or the crucible. It is attached to the weighing arm of microbalance. There are different types of crucibles used, such as shallow fans, deep crucibles, loosely covered crucibles, and retort cups. They are made from the platinum, aluminum, quartz, or alumina, and some other materials like graphite, stainless steel, glass, etc. The sample holder is made from these following materials. And another component is furnace. The furnace should be designed in such a way that it produces a linear heating range. It should have a hot zone which can hold sample and crucible, and its temperature corresponds to the temperature of the furnace. The temperature range can affect the internal atmosphere of a furnace chamber. Therefore, it is necessary to choose the specific type of furnace according to the temperature ranges. Coils used are made of different materials such as nichrome wire or ribbon, platinum, 10% of rhodium alloy. Then the size of furnace is most important. Then recorder, the output from the microbalance and furnace are recorded using either chart recorder. The recording systems are mainly of two types: time-based potentiometric strip chart recorder and XY recorder. In the XY recorder, we get curves having a plot of weights directly against the temperatures. However, the percentage of mass change against the temperature or time would be more useful. Then heating rate, it is the rate of temperature increases which is customarily quantified in the degrees per minute. The heating or cooling rate is used to be constant when the temperature time curve is linear. Then time measurements, it is done by thermocouple. Different materials are used for measuring the different ranges of temperature such as chromal or Almel thermocouple are used for temperature up to 1100 degrees Celsius. Then factors affecting the thermogravimetric curve. The factors which may affect the thermogravimetric curve are classified into two main groups. First one is the instrumental factor, second one is the sample characteristics includes. The instrumental factors, furnace heating rate, furnace atmosphere, and sample holder. The sample characteristics, it includes the weight of the sample, sample particle size, heat of reaction, compactness of the sample, previous history of the sample. These are the factors affecting the DG curve. Then instrumental factor, furnace heating rate and furnace atmosphere. The temperature at which the compound decompose depends upon the heating rate is high. The decomposition temperature is also high. The heating rate of 3.5 degrees Celsius per minute is usually recommended for reliable and reproducible thermogrammetry analysis. The furnace atmosphere, the atmosphere inside the furnace surrounding the sample has a profound effect on the decomposition temperature of the sample. A pure nitrogen gas from a cylinder passed through the furnace, which provides an inert atmosphere. So these are sample characteristics based on the weight of the sample and the particle size of the sample. And these are the applications of thermogravimetric analyzer. Physical transition, chemical transition, loss of drying, purity of analyte, stability of analyze, determination of bound and unbound water begins at room temperature due to the dry gas flowing over the sample. DGA, we can determine the purity and thermal stability of both the primary and the secondary standard. And corrosion study, automatic thermogravimetric analysis, evaluation of suitable standards. These are the applications field of thermogravimetric analysis. So thank you for watching.